Why secondary heat exchangers crack and rust. A complete step-by-step guide for homeowners. Introduction. One of the most confusing and frustrating problems homeowners face with modern high-efficiency furnaces is the failure of the secondary heat exchanger. Many people assume that if a furnace is less than 10 years old, it should be reliable and problem-free. Unfortunately, that is not always the case. Secondary heat exchanger cracks and rust are becoming more common, especially in high-efficiency furnaces designed to extract maximum heat from combustion gases. When this component fails, homeowners are often presented with expensive repair or replacement options, sometimes with little explanation of why the failure occurred. This speech is designed to clearly explain what causes secondary heat exchangers to crack and rust, why these failures happen earlier than expected, and how homeowners can protect themselves financially by understanding warning signs and taking preventative steps before the problem becomes severe. By the end of this explanation, homeowners will understand not only the technical reasons behind secondary heat exchanger failure, but also how to make informed decisions that protect their safety, comfort, and budget. Step 1. Understanding what a secondary heat exchanger does. Modern high-efficiency furnaces, especially 90% plus efficiency models, use two heat exchangers: a primary heat exchanger, a secondary heat exchanger. The secondary heat exchanger exists to extract additional heat from exhaust gases before they leave the home. It captures heat from water vapor created during combustion, which allows the furnace to operate at much higher efficiency. That efficiency sounds great, but it comes at a cost. The secondary heat exchanger is constantly exposed to moisture, condensation, acidic byproducts, temperature changes, restricted airflow. Over time, these conditions create the perfect environment for corrosion, rust, and cracking. Step 2. Why moisture is the biggest enemy. The number one reason secondary heat exchangers fail is moisture. Unlike primary heat exchangers, secondary heat exchangers are designed to handle condensing exhaust gases. That means water forms inside the exchanger every time the furnace runs. This condensation is not pure water. It contains carbonic acid, nitric acid, sulfuric acid in trace amounts. These acids slowly eat away at the metal surfaces from the inside out. Even stainless steel and coated metals are not immune forever. Over time, protective layers break down, allowing rust to form. Once rust starts, it spreads quietly, often unnoticed until damage is severe. Step 3. Acidic condensate and metal degradation. The water produced inside a secondary heat exchanger contains carbonic acid and trace amounts of other corrosive compounds. These acids attack protective coatings and metal surfaces from the inside out. Once corrosion begins, it does not stop on its own. Rust spreads gradually, thinning metal walls and weakening structural integrity. As metal weakens, it becomes more susceptible to cracking due to thermal stress. This process happens slowly and silently, often without obvious symptoms, until the damage is already advanced. Step 4. Poor drainage accelerates rust. Condensation must drain properly out of the furnace. When drain systems become clogged, misaligned, frozen, or improperly installed, water pools inside the secondary heat exchanger. Standing acidic water dramatically increases corrosion speed. Even a partially restricted drain can shorten the lifespan of a heat exchanger by several years. Routine drain maintenance is one of the most overlooked yet critical factors in preventing secondary heat exchanger failure. Step 5. Airflow restrictions cause overheating. Restricted airflow is one of the most common contributors to heat exchanger cracking. Dirty air filters, blocked vents, undersized ductwork, failing blower motors, or dirty evaporator coils all reduce airflow through the furnace. When airflow is restricted, heat builds up inside the heat exchanger beyond its designed limits. Repeated overheating causes metal expansion and contraction. Over time, this stress leads to metal fatigue and cracking, especially in areas already weakened by corrosion. Step 6. Oversized furnaces increase stress. An oversized furnace cycles on and off frequently, Short cycling prevents the system from operating long enough to evaporate moisture properly. This leads to increased condensation, uneven heating, and repeated thermal stress. Oversized furnaces experience more rapid temperature swings, which accelerates metal fatigue in the secondary heat exchanger. Many furnaces are oversized due to improper load calculations during installation, a mistake that often reveals itself years later through component failure. Step 7. Installation errors and design flaws. Incorrect venting, improper exhaust pipe slope, incorrect combustion air setup, or poor alignment during installation can all cause moisture to accumulate where it should not. Some secondary heat exchanger designs have narrow passages that are prone to clogging with debris or corrosion buildup. When exhaust flow is restricted, condensation increases and corrosion accelerates. Not all failures are caused by homeowner neglect. Many are rooted in installation or design limitations. Step 8. Material fatigue over time. Even under ideal conditions, secondary heat exchangers operate in extreme environments. Constant exposure to heat, moisture, and chemical byproducts gradually weakens materials. Metal fatigue is unavoidable over long periods. Once corrosion reduces wall thickness, cracking becomes much more likely, even under normal operating conditions. This is why some secondary heat exchangers fail earlier than homeowners expect. Step 9. How rust leads directly to cracks. Rust weakens the metal structure of the heat exchanger. As corrosion progresses, the metal becomes thinner and less able to withstand heat stress. Eventually, small cracks form. These cracks expand with repeated heating cycles, allowing combustion gases to escape into areas where they do not belong. By the time visible rust or cracking is detected, internal damage is often extensive. Step 10. Safety risks of a cracked secondary heat exchanger. A cracked secondary heat exchanger is considered a serious safety issue. It can allow combustion gases to mix with indoor air, potentially increasing carbon monoxide levels, even if carbon monoxide detectors do not alarm. Any confirmed crack requires immediate attention. For safety reasons, technicians are required to shut down furnaces with confirmed heat exchanger damage. Ignoring this issue puts occupants at risk and can lead to more severe system damage. Step 11. Early warning signs homeowners should watch for. Homeowners should remain alert for warning signs such as unusual odors, frequent furnace shutdowns, visible corrosion near drain components, water leaks, changes in flame appearance, or inconsistent heating. These symptoms do not always indicate a cracked heat exchanger, but they signal the need for professional inspection. Early detection can prevent catastrophic failure and reduce repair costs. Step 12. Repair versus replacement, making the smart choice. If a secondary heat exchanger fails, warranty status matters, labor costs matter, furnace age matters, overall condition matters. Sometimes replacement makes sense. Sometimes repair is reasonable. The key is informed decision-making, not panic. Final message to homeowners. Secondary heat exchanger failure is rarely sudden. It's usually the result of years of moisture, heat stress, airflow issues, and missed maintenance. Understanding how and why these components fail puts power back in the homeowner's hands. The best money you can spend is preventive care, not emergency replacement. A furnace that's cared for properly lasts longer, runs safer, and costs less in the long run. Disclaimer: this content is for educational purposes only. Furnace inspection, diagnosis, and repairs must be performed by a licensed HVAC professional.